Hello everybody, it's dumplet here. Here's an item on triangles involving the use of the law of sines. So triangle ABC has tangent A equals 3/4 and tangent B equals 21/20. Find the value of AC over BC. As usual, pause this video if you'd like to give this item a try, but if you're done, let us dive into the solution. Alright, so this item involves the sine law, and how do we realize that this question is solvable by the sine law is that, look at the given. We're asked about a ratio of sides, and usually if we're given a ratio of sides, then we can try to incorporate the law of sines, and here is why. Because suppose we have triangle ABC here, so angle A is the angle at vertex A and angle B is the angle at vertex B. So the following equation will hold, and this is because of sine law. So BC over sine A would be equal to AC over sine B. So note how we have ratios that are equivalent, that are equal. So simple manipulation would give us the desired ratio, AC over BC. So we can manipulate this to AC over BC, and we can get that this is equal to sine of B over sine of A. Now note how in the item we are given with the tangent of the two angles, so we can easily get the sine of the angles via some trigonometric knowledge. Now since we only need the sine of B and the sine of A, so let's try to convert the given tangents to sines. So these are the two given tangents, so let's start with angle A first. Now we know the identity that the tangent of let's say tangent x, we know that tangent x is equal to sine x over cosine x. So we can utilize this fact and get the respective value for sine and cosine. Now before that, note how in both cases the tangent of A and the tangent of B, they're positive. So we would know where the terminal side of these two angles are. So it's either in quadrant 1 or in quadrant 3. Now we can already immediately rule out that it cannot be in quadrant 3, since we know that A and B are angles in a triangle, and angles in a triangle should be between 0 to 180. So we can conclude that the terminal sides of angles A and B are in quadrant 1. Now since both are in quadrant 1, then we can conclude that sine of x and cosine of x, they would both have a positive sign. Alright, now going back to getting the sine of A and the sine of B. So since we have tangent A equals 3/4, so we have 3/4 is equal to sine of A over cosine A. Now it's a very famous Pythagorean triple that 3, 4, 5 is a right triangle. So just from this alone, we can conclude that sine A must be 3/5, and then cosine A must be 4/5, because 3/5 over 4/5 would indeed give us 3/4. So just from looking at tangent A equals 3/4, we can immediately conclude that sine of A is equal to 3/5. So we are done with one of the angles, so we know that sine of A equals 3/5. Now similarly, we can do for tangent of B. So we know that tangent of B is 21/20, and this would equal sine of B over cosine of B. Now similarly, we have a famous Pythagorean triple, 20, 21, 29. So these are sides of a right triangle. So we can immediately conclude that sine of B would be 21/29, and cosine of B would be 20/29. So, and this ratio would indeed be 21/20. So just from this expression, we're able to get that sine of b would be indeed 21 over 29. So let us write that down. We have sine of b to be equal to 21 over 29. So since we already have sine of b and sine of a, all we have to do is substitute them into this expression. Since we have AC over BC equals sine B over sine A. So we know that sine of B is 21 over 29, and we know that sine of A equals 3 over 5. We can write this as 21 over 29. Since we're dividing by 3/5, that's the same as saying multiplying by 5/3. So we can do some cancellations here. So it's going to be 1 and 7 for the 3 and 21. So we would get the final ratio of AC is to BC. It's 7 times 5, so 35, divided by 29 times 1, which is 29. And thus we'll arrive at our final answer, AC over BC equals 35 over 29. And this is indeed our final answer. So hopefully you guys learned something new from this video, and I'll see you guys in the next one. Bye bye!